Good morning everyone, how's it going today? Welcome to this new video tutorial in which I'm going to show you exactly how to build this application that you see right here. It is a chatbot that allows you to chat with multiple PDFs from your computer at once, okay? Let me show you how it works. And for this example, I'm going to be uploading the Constitution and the Bill of Rights. Then when I click on process, it's going to embed them and put them into my database. Right here, now I can start asking questions about this. So for example, what are the three branches of the United States government? That is a question related to the Constitution. But then I can ask a question also about, for example, the First Amendment, which is in the Bill of Rights. And it's also going to be able to answer me. It only answers questions that are related to the PDF documents that you upload. So it really is only about the information that you provided. I'm going to be showing you how to build this not only using OpenAI, but also using Huggingface free models so that you don't break your wallet while trying to learn how to do this. Yeah, it's a little bit more complex than the previous projects that I had shared in this channel, but be sure to follow to the end. I'm sure that the result is worth the effort. I hope you enjoy it, and if you like videos like this, don't forget to subscribe. Alright, so let's start with this setup right here. Real quick, I'm just going to guide you through. I have already created my virtual environment right here, and which is where all of my dependencies are going to be installed. As you can see, I am using Python 3.9 for this one. We're going to be using our .env file to store our secrets, gitignore, which is the file that tells Git to ignore these two files so that our secrets and our local configuration are not tracked on Git. Here is just my document of my Python version, and this is app.py, which is where all of the action is going to be taking place. The first thing that we're going to want to do is to install the dependencies that we're going to need. In order to do that, you can do pip install, and the dependencies that we're going to need are Streamlit, first of all, to create the graphical user interface. We're going to be using PyPDF2, like that, in order to read our PDFs. We're going to need LangChain to interact with our language models. We're going to be using Python.env in order to load our secrets from .env. We're also going to be using Vice CPU as our vector store. We're going to be using OpenAI and Huggingface Hub, because I'm going to be showing you how to do this both with OpenAI models and with Huggingface models, okay? So once you do that, you hit enter, and it's probably going to take way longer for you because I already have this installed. But yeah. Now we can actually start coding now that our environment is completely set up. Alright, so now let's start with the graphical user interface, okay? First of all, I'm going to first make this test real quick right here. This basically just tests that the application is actually being executed and not being imported. So whatever is inside this condition right here is only going to be executed if the application is being executed directly, not if it's imported. That's kind of a manual test that you usually do. And then you create your function right here, and whatever is inside of this function is what is going to be run in the application. So if I say here, for example, print hello world, and I run it, you'll see that I see hello world right here, because I'm executing it. There you go. So now let's start with the graphical user interface. As I mentioned before, we're going to be using Streamlit for the graphical user interface, and to do that we're going to start by importing Streamlit that we previously installed. So we do import Streamlit as st, as we do, and then the first thing that I want to do is to set the page configuration, okay? So you do st set page configuration. I'm just going to pass in two parameters, but you can pass as many as you want from here. And I'm going to set the page title to chat with multiple PDFs. like that. And I'm also going to pass in a page icon like that. And I'm going to set it to the emoji of books. Also here, I'm going to add a header. Why not? st header like that. And I'm just going to say, like, this is going to be the main header of the application. Going to say that it's going to be also chat with multiple PDFs like that. Like that. And also it's going to add the emoji right here of some books. And also remember that below the header, we wanted there to be a text input where the user was going to be able to add their questions. So let's add that, st text input like that. And whatever you put inside of here is the label from the input. So you can say ask a question about your documents here, like that. That's going to be like the label that's going to appear on top of the user, on top of the text input. And then something else that we want to do is we wanted to add a sidebar where the user is going to be able to upload their PDF documents. So in order to do that, you do st sidebar. And if you want to put things inside it, you have to do with st sidebar and then colon, and then whatever you put inside of here is going to be inside of your sidebar. Okay. Watch out. Do not add parentheses here because otherwise that is not going to run. You will have to pass in some parameters right here and you don't need that. So just leave it like that. And here just write the contents of your sidebar. In our case, we're going to be adding a subheader that reads your documents. And right here, we're going to add another Streamlit component element that allows you to upload files right here. And this one is called st file uploader. There you go. And just as with the text input, inside of the parentheses, you just add the label, okay? Label, as you can see. And my label is going to be upload your PDFs here, and sorry about the ambulance. Upload your PDFs here and press on and click on process like that. There you go. I suppose that's pretty much good. Let's just add a button, st button, and the button is going to be process like that. Now if I click on save, and remember how you run your Streamlit application, you don't do Python app because that is not going to work. You have to run it by with using Streamlit. So you have to do Streamlit run app.py. So you do Streamlit run and then the name of your file, which is in my case app.py. And now the app is running. And as you can see, I have my graphical user interface right here. And something happened here. There you go. I have my user interface right here. And it seems to be working correctly. Now here I can ask questions and all. Here I can upload files. In this case, the files I want to upload are the Bill of Rights and the Constitution. But so far it's just the graphical user interface. There's nothing happening behind. So yeah, let's add some logic to it, all right? Right, so what we're going to want to do is to create our API keys. Because we're going to be using some services by OpenAI and by Huggingface. So we're going to be able to connect to their APIs. And in order to do that, we're going to be needing their API keys. The API keys, we're going to be storing them inside of our .env file because that is the place where you put things that are supposed to be secret and they're not supposed to be tracked by Git. So whatever you put in here is not going to be tracked on GitHub when you upload your repository to GitHub. Okay, that's a way to keep your secrets away from the public. And the way to do this is we're going to create two variables right here. One is OpenAI API key, and the other one is Hugging Face Hub API token. And let's go create them. In order to create it at OpenAI, you have to go to platform.openai.com, create an account, and then go to Account API Keys. And then here you just create a new API key. I'm just going to call it PDFs. You create it, and then you copy it, and then you come right here and paste it here. Same for Hugging Face. You're going to go to huggingface.co, settings, tokens, and then you can create a new token. And I'm going to say that this one is also PDFs. I think read is more than enough, but I'm just going to give it right in case I want to use it again. I copy it, and then I paste it right here. There you go. So now that I have my API's key set, I need to be able to access them from here. In order to be able to access them, I have to first use this other package from Python that we installed before. And this package is called load environment, I think. So you say from .env file, we're going to import load.env. There you go. And this is the function that you're going to run inside of main in order to enable your application to use your variables inside of .env. So here, let's just run load.env. And now LangChain is going to be able to access all of our API keys right here. Okay, that's why, since we're going to be using LangChain, remember that we have to name our variables exactly like this. If you were dealing with your own framework, you can name the variables as you want. But since we're going to be using LangChain, LangChain has its very specific way to name the API key variables. So just remember that you have to name it like this, and then just include load.env right here. And there you go. Now we click save, and now our API keys are set, and we can start dealing with the rest of the logic right here. Alright, so what I'm going to do now is I'm going to show you how this, the logic of this application works. If you have already watched the previous video on PDFs and how to chat with a PDF, this is going to sound very familiar to you. If you haven't, be sure to watch it, because that's a much more thorough and detailed explanation of how this application works. But in case you just want like a real quick refresher, I'm going to cover it real quick right now. But if you do want a detailed description with examples and everything of how this process works, take a look at that video, because it's going to make it easier for you to understand what is going on. So just like real quick, what we're going to be doing is we're going to be taking the PDFs from our user. We're going to be taking several, as many as he wants. And these PDFs, we're going to divide them into pieces of text. Okay, so we're going to read all of the text from our PDFs. We're going to have then just a huge string of text. And that string of text, we're going to divide it into smaller pieces and chunks of texts. Okay? It is those chunks that we're going to later convert into embeddings. Now, what are embeddings? Embeddings are, you can think of that in a very simple way as a vector representation of your text, or a number representation of your text. And something very important about this string of numbers, of this list of numbers that represents your text, is that this list of numbers also contains information about the meaning of your text. Okay? This means that we can potentially find similar text that has similar meaning to your text just by seeing their number representation. And that's exactly what we're going to be doing later. So once we have the vector representation of each of your chunks of text, we're going to be able to store all of those embeddings or your vector representations into a vector store or a knowledge base. This is basically just your database of all your vector representations. And this database, it can be Pinecone, it can be Chroma, it can be Fize. In our case, we're going to be using Fize. But Pinecone is just like the most popular one, so I just added this logo right here to help you see what's going on. But now that we have our database right here, we're going to be able to take this. We're going to be able to take questions from our user. The user is going to ask a question, like for example, what is a neural network or something like that, and then the question we're going to embed it using the same algorithm as we did with the embeddings in our chunks of text. That is going to allow us to find inside of this database the vectors or the vector representations that are similar from all of these chunks of text, we're going to find the ones that are similar or have similar meaning or semantic context to our question that our user asked. That way, this is going to give us our ranked results of the chunks of text that are relevant to the question that our user asked. And we're going to be able to send all of those, send that as context to our language model. So actually the language model doesn't really know what the PDFs have. What we're actually doing is the language model is already trained. Our language model can come from Huggingface or it can come from OpenAI or something like that. But the language model doesn't really know what our PDF documents have. What we're doing is we're finding the chunks of text that are relevant to our user's question, finding them and ranking them in order of importance, and then sending them as context to our language model. So behind the scenes, the prompt is going to look something like, based on the following pieces of text, of chunks of text, answer the following question. And then we're going to pass in the chunks of text selected by our vector store. And we're going to ask the question. And then the language model is going to be able to answer the question depending on the context that we gave it. And then it's going to be able to give us an answer, and that answer is going to be sent to our user. And that's actually what is happening behind the scenes. And LangChain makes it extremely easy to do all of this with just a few commands. So let me show you how that works. All right, let's do that. All right, so what we're going to do now is we're going to be dealing with the sidebar right here. Remember that we have our document drag and drop here, but so far it only takes one file, as you can see, only one file allowed. So we're going to enable multiple files. And we're also going to be dealing with what to do when the user clicks on the process, okay? So let's do that. In order to take more than one file, we're going to come right here to our sidebar and to our file uploader. And there's actually a very convenient parameter called accept multiple files. We're just going to set it to true, like that. There you go. And we're going to store the contents of this file upload into a variable called PDF docs, like this. And now what we're going to want to do is we're going to want to do something whenever the user clicks on the button. So in order to do that, we just have to add an if before the button. That way the button will become true only when the user clicks on it. And then we're going to have to actually start processing information right here. And inside this button, what we're going to do is three things. Remember that first of all is we're going to get the PDF text to get just the raw contents of the PDFs, of all the PDFs. Then we're going to get the text chunks, which is this part right here, to divide it. And then we're going to get the vector store, to create our vector store with the embeddings, okay? So create vector store. There you go. We're going to be building these three different functions in a moment, but before that, I'm just going to show you that actually something very useful to do when you're dealing with these kinds of processes, especially when you're dealing with Streamlit, is to add a spinner right here. So you do st spinner, and then you just say processing or something like that. And then just like with the sidebar, you do with spinner. There you go. And then just wrap everything inside of it. And what this does is that all the contents inside the spinner are going to be processed while the user sees like a spinning wheel. And it just tells the user that the program is actually running and processing things, and it's not frozen. So it's just for to make it more user-friendly, okay? So there you go. Now we can actually start dealing with these applications, with these functions. Now we're going to get the text from the PDFs, all right? So let's do that. All right, so now what we're going to do is we're going to take all of the raw text from our PDFs, okay? In order to do that, I'm going to create a new variable called raw text right here, and I'm going to create a new function called get PDF text like this. And this function is going to take our PDF documents like that. Okay. The objective of this function is to take our PDFs documents, which is a list of PDF files, and it's going to return a single string of text with all of the content, all of the text content of these PDFs. Okay. So let's create that function up here. There we go. So the function is going to be called like this, and actually we're going to be needing a library that we installed before, and this library is PyPDF. So we're going to import it from PyPDF2. We're going to be importing a class called PDF Reader. All right, and you will see how we use it in a moment. So inside of this function, what I'm going to do is I'm going to first of all initialize a variable which is going to contain all of the raw text of my PDFs. And then I'm going to loop through all of my PDF objects right here and read them. And read them and take the contents of that and append it, concatenate it to this variable right here. So let's do that. Now what I want to do is that for PDF in PDF docs, I'm going to want to initialize a PDF reader object. And this object right here, you have to initialize it with the PDF object that you want to initialize it from. And what it does is that it creates a PDF object that has pages. And it is actually the pages that you're able to read from. So what we're going to do is we're going to loop as well through the pages to actually read each page and add it to the text. So now for page in PDF reader, PDF reader dot pages, then this page contains the method called extract text like this. And this one just extracts all of the raw text from this page of the PDF. And we're going to be appending it to our text variable and returning our final text variable in the end, like this. So let me just repeat real quick what happened right here. So we initialized a variable called text, in which we're going to be storing all of the text from our PDFs. Then from each PDF, we started looping through all of our PDFs. We initialized one PDF reader object for each PDF, and then we looped through all of the pages of each of these PDFs, and we extracted the text from that page and appended it or concatenated it to our text variable right here. So in the end, what we should get is just a single string with all of the contents from our PDFs inside of this variable called raw text. Let me show you real quick how this looks. So if I do stwrite and I just write the raw text right here, I'm supposed to see, I think I stopped the application, yeah. There you go. Now, what you should see when I upload my documents right here and I click process, you should see that it, first of all, shows a spinner saying processing, and then it displays the raw text because that's what we're getting right here. So let's do that. I'm going to be uploading the Constitution and the Bill of Rights, and then if I click on process, you will see that now I have all of the text right here. And now I am able to actually divide it into chunks of text. So let's do that. All right, so what we're going to want to do now is to split this huge piece of text into chunks that we're going to be able to feed our model like this, okay? And if you had seen the previous video, you already know what I'm going to do. It's actually very simple. I'm just going to create a new function right here. I'm going to say that I want to get the chunks text chunks like here. And this function is going to be called get text chunks like that. And right here, we're just going to pass in a single string of text, and this one is going to return a list of chunks of text that we're going to be able to feed our database. Okay, so let's just create this function right here. We come up here and we do define this. There you go. Now, in order to divide our text into chunks or pieces or paragraphs, we're going to be using a library. We're going to be using LangChain. Okay, so we're going to be using a class from LangChain called character text splitter. So we're going to do from LangChain dot text splitter. We're going to import character text splitter like that. Okay, and this is the one that we're going to be using to divide our text right here. So first of all, we're going to create a new instance of it. We're going to say that our text splitter is going to be a new instance of character text splitter. And actually, character text splitter takes several parameters. The first one, as you can see right here, is the separator. And we're just going to set it to say that the separator is going to be a single line break. Then we're going to say the chunk size, like this. Now, in this case, we're going to set the chunk size to 1,000, which means 1,000 characters. And then we're going to set a chunk overlap to 200. Okay, just to be clear, the chunk size is the size of the chunk like this. So if you start here, 1,000 characters, probably going to go somewhere like here. And then the chunk overlap is basically just to protect you. Whenever your chunk ends in a place like this, you're going to want to take the previous. I mean, you're not going to want to start the next one right here because you're going to lose all the meaning from this sentence. So the overlap is just going to start the next chunk a few characters before. So if it's 200, it's going to start the next chunk 200 characters before, to be sure to contain all the full sentences and to contain all the meaning that you need in a single chunk. Okay, so that's the chunk overlap. And then the length function like this is going to be the length function from Python. Okay, and then basically we're just going to create our chunks from our text splitter. We're going to say split text, and we're just going to pass in the text right here, like that. And then we're just going to return the chunks like that. So if I'm not mistaken, right now we should have this element right here that contains our split text method, and that will just return to us a list of chunks of about 1,000 character size and with an overlap of 200. So let's see how that looks. So now that we have this right here, we can just st write it and to display it in our sidebar right here. So let's just refresh this page right here. And let's load again our two documents. We can click on process, and there you go. So now you have that the first chunk is this one right here, the second one is this one right here, and as you can see, this one starts like here. Okay, so that's the overlap in action. So there you go. Now you have all of your chunks divided, and now it's time to actually use those chunks to create the vector store. Okay, so now we created this, and now we are going to do this part right here, and it's very quick, so bear with me, right? All right, so now that we have our chunks of text, what we're going to want to do is we're going to create our embeddings. Okay, now our embeddings, if you remember correctly, are here. It is this part right here, which is the part in we create the vector representation of our chunks of text in order to store them in our database so that we can run this semantic search to find similar chunks of text that will be relevant to our question. I'm going to be showing you two ways of doing this. The first way I'm going to be showing you right now is by using OpenAI's embedding models. Okay, now this is paid for, so you have to keep that in mind in your business model if you're going to be loading documents that are thousands of pages long. But the prices are right here. If you go to openai.com/pricing, embedding models, like the latest one is like ridiculously cheap anyways. I remember someone saying on Twitter that you could embed the entire transcription of Joe Rogan's podcasts for $40 or something like that. So, I mean, it's not super expensive, but it's definitely something to keep in mind in your business model. Okay. That's the first one. And the second one that I'm going to show you is a free one called Instructor. And this one is actually very good. However, you do have to have it's going to be way slower if you're just running it in your computer and expecting it to just make all of the embeddings in your CPU. You got to have a GPU or something like that in order for it to be performant. However, something that I wanted to mention is that unlike with language models like GPT 3.5 or GPT-4, where pretty much are the benchmark for how a language model should be so far, like OpenAI's language models are undoubtedly the best on the market. So they're like other models are measured compared to them. However, when it comes to embedding models, they are not at the top. If you see right here the official, leaderboard from Huggingface, you can see that OpenAI's model, which is Ada V2 here, is actually on 6th position, and Instructor, which is the one that I'm going to show you how to use, is on 2nd position. And it's probably the one that I would recommend if you have your own hardware. But yeah, just keep that in mind. That Instructor, you're going to have your own hardware, or I'm not sure if they make it available here on Interface API, but it might be available on Hugging Face. But yeah, just keep that in mind. And let's get to doing the OpenAI one for now. All right, so let's now create our vector store from these text chunks right here using OpenAI's embeddings. So I'm going to do vector store equals get vector store. And we're going to do it from the text chunks. All right. And then we're going to have to define this function right here. I'm going to define it down here. There you go. And this one actually is a very simple function. Since we're going to be using, for now, OpenAI's embeddings, we're going to do from Langchain.embeddings import OpenAI embeddings. And we're also going to be using FICE as a vector store. Okay, FICE is pretty much just like Pinecone or like Chroma or whatever. It's just a database that allows you to store all of these numeric representations of your chunks of text. Okay, the different thing about FICE is that it runs locally. So in this case, we're going to be storing all of our generated embeddings in our own machine instead of in the cloud or something like that. So this is going to be erased when we close the application. Probably in another video I'll show you how to use an external persistent database. But for now, let's do Langchain.vectorstores. We're going to import FICE. There you go. So here we're going to say that the embeddings are going to equal OpenAI's embeddings. And then we're going to say that the vector store is going to equal our FICE, and we're going to generate it. Right now we're creating the database, okay? We're going to be generating it from texts, okay? Because we have the chunks of text right here. And this one takes two parameters. The first one is the chunks, the actual text, which are going to be our text chunks, chunks of text. And the second one is going to be the embeddings. and here we take the embeddings that we just created. All right. So, and this is the one that we're going to return. Return vector store. There you go. So yeah, there you go. Now we have successfully created this vector store right here by using OpenAI's embeddings. And let me just show you how fast that is, because we are sending just the chunks of text to OpenAI servers, and then it is them who are doing all the heavy lifting. So let me do this streamlit run. 1 second. Streamlit run app.py. Let's see how that looks like. There we go. We have the application running right here. I'm going to upload the same files as before. I'm going to click on process, and let's see how long it takes to process. Remember that we're using the OpenAI's API key that I set before, and now it's ready. All right, so that wasn't very long, and it's OpenAI servers which did that. If we want to do it in our own computer, we can use the the Instructor API, and let me just show you how to do that right now. All right, so now I'm going to show you how to do exactly the same thing. I mean, remember that we have just successfully created our vector store, which is our database with all of our embeddings, but do that for free, okay? Before, like just a moment ago, I was charged for what I did for embedding the 20 pages-ish of my 2 documents, all right? So now we're going to do it in my machine, and we're going to do it for free. So let's see how that looks like. We're going to be using, just as I mentioned before, the Instructor Embeddings. And as you can see, it is actually ranked higher, as I mentioned before, it's ranked higher than OpenAI's embeddings. So let's click on that one, and this is the one that we're going to be using. However, something that's important to keep in mind is that I forgot to mention that you have to install a couple more dependencies for you to use this. So you're going to do pip install, and the 2 dependencies that you're going to need are first of all the Instructor embedding, which is the main package that we're going to be using, and then sentence transformers, which is just a set of dependencies that our Instructor embedding is going to use. However, do keep in mind that this was super fast for me, but these are pretty heavy packages. So don't worry if it takes several minutes for you to actually finish downloading. And then once that's installed, you can actually come right here. It's inside the same module, LangChain Embeddings. You come right here and you say Huggingface Instruct Embeddings. And here, just instead of doing OpenAI Embeddings, we're going to initialize a new Embeddings. And this time we're going to call it from Huggingface Instruct Embeddings. Okay? And this one actually, we're just going to pass in the model name. And the model name for this one is exactly this one that you see right here. Remember that this is the one that we're going to be using. So we just take this and we just paste this right here. And now we should be able to pass in these embeddings that we just created from our Huggingface embeddings into our vector store right here. And it should work. However, as you will see, it's going to be way, way slower. Let me just show you what I mean. So if I do streamlit run app.py, I'm going to put this on the side like this. I'm going to get rid of this. I'm going to show you on the terminal right here. And if I bring my application up here, this, as I mentioned before, this is barely 20 pages or something like that. And remember that just before, for OpenAI, it took like 4 seconds for it to embed everything. Now if I click on process right here, you will see that it starts to process, it loads the transformer, and as you can see, it's loading in my computer, okay? So it loads the transformer, then you will see that it loads the CPU, etc. And so here you have like the start time, all right? It started with my CPU, I'm going to pause the video right now, and let me just show you in a moment how much it actually took to embed only 20 pages, all right, in my computer using CPU. I don't have a GPU connected to this one right now. So let's see. All right, so it finally finished. It didn't actually take that long. It took 2 minutes to do it in my computer. However, like, do keep in mind that this can easily scale up if your computer is not powerful enough, or if you're just relying on a CPU. Okay, so yeah, so that's how to do the instructor embeddings in your application. Now, what we're going to do is we have successfully finished all of this part. We can actually do this, and LangChain actually allows you to do that super quick in just one single chain. And we're going to include memory in it super quick as well. So let me show you that in just one moment. All right, so now it's time to start creating this part right here. And it's actually super quick and super simple because LangChain provides a chain that allows you to do this out of the box. Okay. And it's actually very convenient because it allows you to add memory to it. So this means that you can ask a question about your document and then ask a follow-up question about the same thing that you're talking about. And the chatbot is going to know the context of your question. Okay. So let me show you how to do that real quick. We're going to have to come right here, and then we're going to have to create an instance of this conversation chain. Okay. So I'm actually going to create a new function for that. I'm going to say create conversation chain. So I'm going to call this conversation, and I'm going to store it in, I'm going to create a new function just like we were doing, get conversation chain. And this one is going to take my vector store. Okay. There you go. So now let's, just like before, we're going to have to create this function up here. Define, there you go. And right here, we're going to have to initialize a few things. First of all, since we're going to be dealing with memory, a chatbot that has memory, we're going to have to initialize an instance of memory. In order to do that, we're going to have to import this from LangChain. And it's called conversational buffer memory. Okay, so from LangChain .memory, we're going to import conversational buffer memory. So there you go. And now we can successfully initialize it right here. We're going to say memory equals conversational buffer memory that we just imported, like that. There you go. And we're going to set this one. In order to initialize it, we have to set a memory key first of all. I'm just going to call it chat history. And let's say that it returns message. Let's set that to true. Okay. If you want to know more about how memory works in LangChain and how you can use buffer memory or entity memory or other kinds of memories, be sure to check my video. I have a video especially about that, so check it out. And then once we have this memory right here, we can actually initialize the session. So conversation chain, let's call it. And we're going to say that this equals the conversational retrieval chain that I actually haven't imported. So I'm going to say that from LangChain dot, if I'm not mistaken, is from chains, we're going to import conversational retrieval chain, which allows us to chat with our text, with our context, with our vector store, and have some memory to it. So in order to do that, first of all, we're going to say that this one is going to be conversational retrieval chain from language model. And this one right here takes a few things. The first one is the language model that we're going to be using. In my case, let's use let me just initialize it right here. The language model is going to be OpenAI. I'm going to import it from here. LangChain, from LangChain.LLMs, import OpenAI. There you go. So now I can use OpenAI. This one's going to use DaVinci. Actually, you know what? Let's use chat model instead. Chat models. We're going to use chat OpenAI. And here we're going to initialize it with chat model. There you go. Now we can use this LLM right here. So the first argument that our conversational retrieval chain is going to take is the language model. So I'm going to say LLM equals my language model. The second argument is going to be the vector store or the retriever. And I'm going to call my vector store that I took right here. I'm going to say as retriever. There you go. And then my memory is going to be the memory that I initialized just a moment ago. Okay. And now this is my conversation chain. I'm just going to return it. Return my conversation chain. There you go. Now, something important to keep in mind right here is that we have just created our conversation object. Okay. This one right here is going to allow us to generate the new messages of the conversation. This one in a very high level explanation, all it does is it takes the history of the conversation and it returns you the next element in the conversation. Okay, so this is the one that we're going to be using in the entire application later on right here. So it is a good idea to have this persistent during the application. Something about Streamlit is that whenever something happens, like someone clicks on a button or someone submits something on an input field or something like that, Streamlit has a tendency to reload its entire code. So if I click on something or just submit a text input or something, it's going to try to reload the entire thing. And then that means that it's probably going to reinitialize some variables. So if I don't want that to happen, if I want some variables to be persistent over time, I can do st session state, and that way the variable is linked to the session state of the application, and the application knows that this variable is not supposed to be reinitialized. Okay? In this case, we're not going to be doing this especially because of the reinitialization, because this is only triggered when we click on the button. However, this is also useful when you want to use a variable or an object during the entire application. So as you can see right here, we initialize the conversation object right here, but we may want to use it outside of the sidebar, and that would be outside of the scope of this piece of code. So a good thing about the session state is that you can just use it outside of it. If you go to session state dot conversation, this is going to be available outside of the scope. So that's a good way just to use some pieces of some objects outside of your scope if you're using Streamlit. Something important about this is that it is a good practice that if you're using a session state object, you initialize it before. So we're going to come right here, we do conversation, and we're going to test that if it's not in my session state, session st.session state. If it's not in my session state, we're going to initialize it, and we're going to do st.session state.conversation equals none. All right. So this way, if the application reruns itself, it's going to check if conversation is already in the session state of the application, and it's going to reinitialize it. It's going to set it to none if it's not been initialized, and if it has already been initialized, it's not going to do anything with it. So now we can use it anywhere during the application. So that's something important to keep in mind. We're going to do the same thing with the history of the chat messages. But yeah, just so that you know how to make your variables persistent during the entire life cycle of your application, okay? Just to make it clear, this is not about refreshing the application. It only lasts during the session of the application, which is while the application is open, all right? For some reason, Streamlit just reloads some code from time to time. So there you go. There we go. All right, so now that we have done this, actually, I'm going to show you how to display messages, all right? In a previous video, I showed you how to do this using a package from Streamlit called Streamlit Chat, which is pretty convenient if you want to get it up and running real quick. However, I'm going to show you a different way to do this right now, and it's basically just inserting custom HTML into your application, okay? So if you're at ease with HTML, this is probably a good idea for you. If you're not, probably not. But I mean, it's pretty convenient. Here, I'm going to create a new file right here. I'm going to call it, let's see, I'm going to call it HTML templates. How about that? I'm going to call it HTML templates.py. And this is some code that I had already prepared. So what we have here is basically just the styles, the styling from, the CSS styles that are going to style these two classes, chat message and bot. And we have two templates. So this is going to be the template for the user, and this is going to be the template for the bot. Okay. And as you can see, I already added some images right here for the users, but you can add your own just by replacing what's here in the source part as well. All right. And yeah, actually, I don't need this part anymore. Now that I think of it, there you go. So here you go, and here's the message, and this is the part that we're going to be replacing. Actually, I don't like it this way. I usually write my variables like this. There you go. There you go. Now, actually, we can save this, and we can import these three elements into our application on this side. So we're going to say that from HTML templates, we're going to import CSS, we're going to import bot template, and we're going to import user template, okay? And remember that our CSS, we're going to have to add it up here because the CSS is going to, just like in a website, you have to add your CSS on top. So we're going to add it here. We're going to do st-right, and we're going to add our CSS, and we're going to say that HTML it's going to allow unsafe HTML, okay? And then just to show you how it works, outside of the sidebar, I'm going to add it right here underneath the input element. I'm going to say st-right. We're going to say that this is the message, the user message, user template. And then we're going to say that we're going to allow unsafe HTML. This is only to tell Streamlit that it's supposed to show the HTML inside of it. Okay, otherwise it's just not going to parse the HTML as HTML. And this one's going to be the bot template. Okay, and last but not least, let me just show you real quick how to replace this thing inside. I think that in Python the function is replace. Yeah. So in Python what we're going to do is here we're going to say .replace, and we're going to replace the message with my message. Here it's going to be hello human, and here we're going to do the same thing. We're going to replace MSG. We're going to say hello robot. There you go. Let's see how that looks. Now if I refresh right here, I should have, there you go, hello robot and hello human. As you can see, this looks pretty professional, like a chatbot. And here I am, and here's the human, here's the bot. And all I had to do is replace the message variable inside of here with my user template, with my personalized message out here. I suppose that you can start to see how this is going to play when we replace this with our own, message, okay? So let's do that right now with our own conversation. So let's create the conversation and just use these templates to display the new messages. All right, let's do that. All right, so now it's time to actually generate the conversation. All right, so what we want to do is when the user fills something in here, we want to be able to handle that input. Okay, so what we're going to do, actually, first of all, I'm just going to get rid of the Huggingface Instructor Embeddings because that's just too slow. This is just for demonstration purposes, so I'm going to continue using OpenAI Embeddings for now. But now at least you know how to do using Huggingface Instructor Embeddings. Okay. So right now, what I'm going to do is I'm going to come right here to my text input and I'm going to handle the submission. Okay. The thing is, we do user question to store the value from the input in the user question, and then we do if user question. Then this is only going to be triggered if the user submits a question. We're going to handle user input, and we're going to pass in the user question like this. And just as before, we're going to create the function up here. Okay, there you go. And here, actually, this is pretty interesting. We're going to be using the variable that we created just a moment ago in the sidebar, this one right here. We're going to be using it to generate the answer to the user's question. And actually, it's very simple to do that. The way we're going to do this is we're going to, right here, we're going to say the response is going to be equal to st session state. And here's where we're going to be calling the conversation. And right here, we're going to pass a key value pair of question. And right here, we're going to pass in the user question. Okay. And now inside, let me just show you what this looks like. So st write the response. Okay. So now when I submit a question to the user, when the user submits a question, I'm going to handle that input and I am going to write the response from the language model. And remember, this conversation chain already contains all of the configuration from our vector store and from our memory. This means that this one right here, if we use it again, it's already going to remember the previous question. Since I already set up the memory, this is already going, if I keep asking questions, it's already going to remember the previous context. All right. So let's see what this looks like. I'm just going to refresh this, and I'm going to bring my two test files right here again. I'm going to process them. Since I'm using OpenAI, oh no, I didn't rerun OpenAI. I think it's, oh no, yeah, okay. So I can now do, what is the first amendment about? Then if I click enter, it's supposed to tell me the answer to that. However, it's going to return an entire object with a lot of things, all right? So here you have it. It has the answer, and it also has the entire chat history. And that is what's important to us, because remember that we want to submit the entire history of the chat, all right? So we're going to take this object right here, and we're going to show everything up here, everything in the chat history up here, down here, formatted with this template right here. Okay, so let's do that. What I'm going to do then is I am going to just remove this part right here, and I am going to create a new session state variable, and this one is going to be session state.chat history, like this. Okay. And this one is going to be equal to my response, and it's going to be equal to my response object chat history, like this. There you go. And now this one is the one that I am going to be displaying. Now, let's say for I message in enumerate st chat history, like this. This is basically allowing me to loop through the entire chat history with an index and the content of the index. And if I mod2 equals 0, mod not and, if I mod2 equals 0, we're going to stwrite our user template. And remember, just as before, we're going to be replacing message with the message, etc. So let me just paste this right here. Replace message, but this time we're not going to be replacing it with something in particular. We're going to be replacing it with the message. And where is it located inside the message? Inside content. So this is the entire message that we're looping through. And I want only the content of the message. So I'm going to do message.content like this right here. And this is going to, since I did mod2, this is only going to take the odd numbers, all right, of the history. And then else, for the pair numbers of the history, we're going to stwrite as well. But this time it's going to be the bot template. We're going to replace it as well, and there you go. Now we can delete this part right here. And now if I save this, it should work now. Oh, one thing actually, just remember that when you are using session state, you have to initialize it up here, okay, at the beginning of your application. So if chat history doesn't exist, if chat history not in st session state, we're going to initialize it to none so that we can never start using it without actually have it being initialized, okay? All right, so let's go and test it. Right here, I'm just going to drop my 2 test documents right here. I'm going to click on process. And let's see how this works. Now it seems to be processed. I'm running the bill of rights, so it's supposed to know what does the First Amendment say. Let's see if it knows. And now it's supposed to be actually displaying the message templates that I created before. Okay, so there you go. What does the First Amendment say? The First Amendment states blah blah blah. And then let's see if it grasps some sort of context here. So if I say, how about the second one? And if I click this, let's see what it gives us. Just going to put myself here, and there you go. So it knows that we're talking about the Second Amendment because we were talking about the First Amendment before. Okay, so it has some sort of memory. It has this chat-like structure. And yeah, I mean, I hope that you found it useful. I hope that this has been educational. Let me just show you super quick how to do the same thing, but using Hugging Face models instead of OpenAI's models. Because right here, remember, we used Chat OpenAI, but actually we can do pretty much the same thing with Hugging Face. Okay, so in order to do that, just going to copy this that I have right here, and I'm going to paste it right here. So it's pretty much the same thing, but we're going to have to import Hugging Face Hub. So from Langchain language models, we're going to import Hugging Face Hub, and now we can use it right here. And in this case, I'm just using Google Flan T5, but like you can use any language model that you have right here, right? So if you come right here and you find a model that you want to try with this structure, you just have to remember that we installed before Hugging Face Hub. So this comes with that. You don't have to install anything. I think you don't have to install anything else, but in any case, just read the errors. It usually gives you exactly what dependency you're missing and that you have to install. But yeah, I mean, just write the repository ID right here from Facebook Dino. I don't know. I mean, just choose a language model that works and then you set the temperature. For this one in particular, temperature temperature 0 was causing problems, but if you put it to anything other than 0, it's supposed to be all right. So I'm just going to test it like this and show you how it works. Just going to come right here, going to refresh this. Let's just load the two files again. And once it's processed, I should be able to ask about the same First Amendment, okay? So what does the First Amendment say? And it's supposed to be calling, Congress shall make no law respecting the establishment of religion, prohibiting free speech there. All right, it's less, here I passed in Google Fluenty 5, but feel free to use any language model. Here I am not running this locally. I am using the Huggingface Inference API. So that means that this is working pretty much just as OpenAI. I'm sending the request to Huggingface and I'm getting it back. But this is free and it's limited just for testing, okay? So I hope this was useful for you. I hope that you enjoyed it. I hope that you have a very nice project that you can now show your employers and your clients. And I hope that you start creating really nice, productive and beautiful applications like this to solve real world problems. If you want to see more of this, be sure to subscribe. And if you have any questions, just let me know in the comments. And congratulations for following up till the end. It was some sort of long and complicated, a little bit more complex project than the ones I had done before. Let me know if you like this kind of project. But I'm going to be continuing publishing content for beginners as well. So thank you very much for watching, and I will see you next time.